Welcome to a video entitled Thinking in SQL. Because what I want to talk to you about here before we jump into a lot of aspects of Transact SQL and how we're going to use it to create tables and change tables and delete tables and then write queries and so forth, I want to just kind of get you up to speed on some things that might surprise you. Working with T-SQL has two important aspects, and these things will confuse you if you're coming from what a lot of people would call a more conventional programming background. Now, it's not unusual. I was this way. Yeah, I know a little C++. I've worked with, back then it wasn't C#, but worked with a little VB and some BASIC and so forth. So I understand this programming thing. Well, okay, you do, but you need to learn to think in SQL when you work here, because let's talk about these two important aspects of SQL and then we'll go a little deeper here. SQL has two important aspects. One is logical processing, and that is how the query is constructed. So this is referring to the syntax and the style of the query that we enter, and this tells the database engine what you want. Now, it's kind of English style based, right? And you can pretty much figure out from looking at the query, just from the English sentence type feel of it, what you're asking the database engine for. Right? We want to see these many columns from this table, where shipping weight is greater than 5 pounds. That makes sense. The physical processing is pretty interesting. This is how the result set is obtained. The database engine has to figure out how to get the results that we ask for. Our job is the logical processing side. We need to get the syntax and the style of the query right. We tell the database engine what we want. And then the database engine, through physical processing, has to figure out how to go get those results and how to bring them to us. Now, the logical processing steps in our mind, we write the queries in this format: select, from, where, group by, having, and then order by. And so we tend to think our query is going to be processed in this order, but that's not so. And if you're coming to this from a more conventional programming background, you're going to notice in a couple of places, and I'll point them out, especially when we talk about table aliasing, that it looks as though that we are using or consuming variables before we've declared them. And here is what's going on. Logically, we see it as select from, where, group by, having, and order by. But notice the database engine processes the query in this order. From goes first, then where, then group by, then having, then select, and then order by. So notice from and select have kind of changed places here. From got moved to the top and select got moved down almost to the bottom. It's not a position for position switch, but this will help you understand why SQL does some of the things it does and why you see some of the result sets that you do, especially if you're not using that order by, and especially if you're aliasing things like tables and so forth. So just keep this in mind. I don't expect you to remember this right now. It's nothing to freak out over. But do remember, if you find yourself one day being surprised by how SQL seems to be using certain aspects of the query, come back and look at this again. And remember, it's not necessarily doing things in the background in the order that you're typing them up. Then there is this thing about query optimization. And you really need to kind of tuck this away back there in your developer brain somewhere, because you will come back to this later on. There is a body of functionality in SQL Server called the Query Optimizer. Now, the Query Optimizer is a collection of functionalities. You can't point to any one place in SQL Server and say, there it is, that little blue thing, that's the Query Optimizer. It's not quite that simple. However, every time we execute a query, the Query Optimizer performs these following steps in this order. It parses the query. Queries parse for syntax to make sure that it can figure out what we're asking it, that syntactically it's correct. It checks to make sure that the objects, the tables, the views, whatever that we're referring to exist in the database and it can find them. It will check our permissions on those objects, and so all that happens. Then the optimizer generates some execution plans. We'll talk about these a little bit later on. But the bottom line is it says, okay, this is what dude's asking for. And he's written his query syntactically correct. I got that. All of his objects are there. He has the permissions to do this. Now, just exactly how am I going to go about producing the results? This could get kind of tricky. And so it looks at a number of different ways that it could produce the results, and then it does a cost assessment of those plans. And it looks at which plan would be the most efficient. Once it's decided that, then it moves on to query execution, where it actually chooses the plan that looks like it would cost the least and give me the results I want. It executes it, and then it caches that plan. So the chosen plan is executed and then saved in cache for later use. Now, this is interesting because if the same user goes back and executes that same query, and that query is sitting out there in cache, there really is a step up here that I didn't mention, and that is it looks to see before it parses it, has this particular query been run and cached before by this user? If it has, I'm going to skip all this stuff and just go grab that execution plan and execute it. Okay, so just kind of stick that in your brain for now. We will come back to this when we talk about stored procedures a little bit later on. But for now, just understand, it really helps to make sure you're thinking in SQL and not thinking in the way that you're normally used to working with programming languages.